The purpose of this video is to introduce the concept of percent yield and talk about how we calculate percent yield. Also in there, we'll talk a little bit about what we mean by theoretical yield. So I'm actually going to start these slides by just bringing back an idea, just going back to the slides that we did on limiting reactants. One of the reactions that we looked at when we were talking about limiting reactants was this reaction of zinc and iodine to give zinc iodide. And in that particular problem, we had 1 gram each of zinc and iodine. And we did the calculation and determined that iodine was the limiting reactant. And the is what I called expected yield of zinc iodide then would be 1.26 grams. I called it expected yield at the time because I didn't want to really take the time to go into detail as to why we call it theoretical yield, and the actual technical official term for what I was calling expected yield in that presentation is called theoretical yield. And why do we call it the theoretical yield? Well, we call it the theoretical yield because it's the amount that we determine from a roadmap calculation. So it's the yield that we determine based on a roadmap 2 calculation. It's the amount of product we would get if, and the ifs are, if we were able to turn every single molecule of the limiting reactant, which in this case is iodine, into product, and that rarely happens. There are usually side reactions that can occur. And if we did that, we were able to recover every single molecule of the product and isolate and purify it. And so in reality, that rarely, if ever, happens because, as I said, there are alternate side pathways that reactions can go down, and it's also nearly impossible to isolate and purify every single molecule of the product that you make. And so it's almost invariably the case that the actual amount of material that we recover and weigh is less than the theoretical yield. Occasionally, you will recover and weigh out an amount of product that's more than the theoretical yield. That really can't actually happen. And so what that really means is that there is some impurity present in your product. Okay, well, the basic idea of percent yield calculation is very straightforward. We're essentially saying whatever we recovered, how much of is that as a percentage of the theoretical yield. And so we simply set this up as dividing the actual yield, which is the amount that we actually recovered, by the theoretical yield. That is what the roadmap 2 calculation said we could make, and then multiplying that by 100. And again, what that does is that just tells us simply the material we actually recovered and weighed, what percentage of the theoretical yield does that actually represent? So let's take a look at an example. Oh, before we look at an example problem, let me just say, because there are 3 variables, that is, the 3 variables are actual yield, theoretical yield, and percent yield. Because there are 3 variables, there are actually 3 different ways that we can rearrange this equation. So we can solve it for percent yield, which is just we were just talking about, which is actual over theoretical times 100. If instead of knowing the actual and theoretical yield, we knew the actual yield and the percent yield, then we could solve for the theoretical yield simply by just rearranging it by multiplying both sides by theoretical and dividing both sides by percent. Or if I knew the percent yield and the theoretical yield, I could actually calculate the actual yield using this third equation. So let's go on and take a look at an example. And here's the example. This is a fun reaction. I've had colleagues who use this as a method of generating acetylene gas. C2H2 is a highly flammable hydrocarbon gas, acetylene. This is a method for generating acetylene gas in a laboratory. That's always fun, probably for the students, but rather terrifying for the teacher, I would think. And that is by taking calcium carbide and just putting it into water, and out bubbles this gas of acetylene. A second product is calcium hydroxide. But the gas that comes out is acetylene gas, and it can be used and burned and turned into all kinds of exciting things. Okay, so here's the setup. We've got this balanced equation. If a 62% yield of acetylene is achieved from the reaction of 17 grams of calcium carbide, how many grams of acetylene were actually produced? So this is an unusual, I mean, this is not an unusual question, but it's different from a straightforward percent yield calculation, because what we're actually being asked for here is the actual yield. So if we go back, we're being asked for the actual yield here. In order to calculate the actual yield, we need to know the theoretical yield and the percent yield. Well, the problem gives us the percent yield. It doesn't give us the theoretical yield, but it does give us the starting amount of calcium carbide. And of course, we can simply do a roadmap 2 calculation in order to make that happen. So let's take our 17 grams of calcium carbide, and let's remember how we do a roadmap 2 calculation. We're going to divide by the molar mass of substance A, the substance we're given, which is for calcium carbide is 64.1 grams. Then we're going to multiply by the mole ratio, which is 1 mole of acetylene for every 1 mole of calcium carbide. And then we're going to multiply that by the molar mass of our product, acetylene, which is 26.0 grams per mole. And we get out of that 6.90 grams of acetylene. So now we're going to plug those numbers into our equation. Again, we're being asked for the actual yield. The actual yield is the theoretical yield times the percent yield divided by 100%. The theoretical yield is 6.9. The percent yield is 60.2. We plug those in, divide by 100%, and we get 4.19 grams. So this video ought to prepare you to work on one of a couple percent yield worksheets that I have. In each case, you are actually going to need to do what we did on the previous slide, which is to do a roadmap calculation to work out the theoretical yield, but in order to be able to calculate the percent yield. But I think that now we're all very skilled at doing that. So thanks for watching.